Hi, this is Miss Park, and in this video we're going to do a little introduction to working with sets. Okay, so if you haven't worked with sets before, a set is simply a collection of items. Okay? And you can see over here I've got a collection of fruit, right? So in math, when we have a collection of items, we give the whole set or the whole collection a letter. We give it a name that's a capital letter, and whatever it is, whatever letter that you want. So let me just go A. I'll call it A. Okay, and then to show that all of these items are in the set A, we say A equals, and then we draw these squiggly brackets called brace brackets, and everything in the brace bracket is in the set. Okay, and another way we can do this is we can write it in words. So I can say the set A equals, and then open my brace bracket, and then list all the things instead of drawing the pictures. So I can go apple, banana, watermelon, pear, pineapple, and lemon. Okay, so that is my set A. Now this particular set A has 6 items in it. So we say that this set has 6 elements. Okay, and an element is just something that belongs in the set, something that is in the set. And so a banana is an element of the set A. So we have a little symbol, it's like a curly E, looks like a pitchfork, and we read it as is an element of. It means that it is contained in this set. The set contains banana. All right, it also contains apple, and it contains lemon, and it contains all of them. Now, a set can also contain another set. So for example, if we take a few of these, so let's say all the yellow ones, okay, then I can make a set that's got the yellow ones. So I can say banana. So notice I'm putting them in the brackets. I'm separating them by commas. Banana, pineapple, and lemon. This entire set is contained in the set A. So we have another symbol to say that a whole set is contained in the set A. So that symbol looks like this, and it's called subset. So we say is a subset of. It means everything in this smaller set is contained in the larger set. So for something to be a subset of something else, it means every element in the first set is also in the second set. So you can see all those yellow fruits, they're in the big set A. Now, sometimes something is not a subset or is not an element. So let's take a strawberry. Okay, a strawberry is not in this set A. So we would write like this. We would go strawberry is not an element of, and so we cross it out. Strawberry is not an element of set A. Okay, and if I go this set, grapes, were there grapes here? No, there were no grapes. So grapes, what else wasn't here? Grapes and strawberry. Okay, so this smaller set, grapes and strawberries, is not a subset of set A. It's not contained. All right, what about bananas and strawberries? So banana and strawberry. Is this set contained in the set A? So let's see. For the whole set to be a subset of A, we need every item in this first set to be in A. Now there is a banana in A, but there's no strawberry in A. So the set of bananas and strawberries is not a subset of A. So it's the subset symbol, but it's not. So we cross it out. Okay, so that's sort of the basics of sets. So we call them with a capital letter. It's just a collection of items. And here's the thing, it needs to be what we say, it's a well-defined collection of items. So well-defined collection of items. So for example, I can have a set that's all yellow fruit, that's fine, that's a set, but I can't really have a set that says all delicious fruit, right? I can't have a set that's the set of all delicious fruit, because delicious is not well defined. What you might think is delicious, I might think is gross. right? So we can't make a set of all things that are delicious because it depends in whose opinion. But we can make a set of all things that are yellow, or all things that have that you I don't know, eat the peel. Okay, so those things you can do. All right, so one last thing about sets. I'm going to bring this picture back again. You may have seen before a Venn diagram. So you might have seen this in previous courses, not even necessarily math. Sometimes we use Venn diagrams for other subjects. And so Venn diagrams show you how the sets are related to each other. So for example, if I look at this fruit again, and if I say A is the set of yellow fruit, okay, and I say B is the set of, what should we say, fruit where we eat the peel. Okay, so I'm going to guess watermelon, we don't eat the peel. Right? And pineapple, we won't eat the peel. And lemon, we won't eat the peel. And also banana. Okay, so apple and pear, we will eat the peel, and the other ones we won't. You can see that we can draw a picture of all the yellow fruit. Okay, this is the set A. And what's in the yellow fruit is banana, pineapple, and lemon. Okay, and in B, the fruit where we eat the peel, we'll call this set B. So I'm making a circle to represent the set. So where do we eat the peel? It'd only be apple and pear. And so if I drew a picture of A and B, I would see A here and B here, and nothing in common. They would just sit like that. Okay? But if I, let's say, make one set A that's called yellow fruit, okay, so it's got banana, pineapple, and lemon, and then another set C that is not fruit where we eat the peel. Let's say it's fruit that begins with the letter P. All right, fruits that begin with the letter P. So I'm going to go in here, and so what are they? They are pear and pineapple. They begin with the letter P. We can see that these two sets, A and C, actually have an element in common. They both have pineapple. So the way we would draw it as a diagram is we would have the set A intersecting with the set C. Okay, so here's A and here's C. They're intersecting. And pineapple is in both of them. So pineapple is in the middle here. Pineapple is in the section that's both in A and C. Then whatever's in A that's not in C is going to be here, banana and lemon. And whatever that's in C that's not in A is going to be here, and that's going to leave me with just pear. All right, now these sets are all contained in the big set of everything. So we draw a box, this is everything. And anything that's in the rectangle but not in the circles is something that is not a yellow fruit and also is not a fruit where we eat the peel. Okay, so I think that would be watermelon. So watermelon would sit on the outside. Okay, watermelon would sit in this big rectangle because it doesn't belong in the set A of yellow fruit and it doesn't belong in the set B, fruit where we eat the peel. Okay, so that sits on the outside. Similarly here, I can draw a big outside. I think this is called the universe. I like to call this the universe, this big rectangle. Well, what's going to be in the universe is anything in my set that's not in that's not in set A and it's not in set C. So it's not a yellow fruit and it's not a fruit that begins with the letter P. So what would that be? It's watermelon for sure, and also apple. Okay, so it's not yellow and it doesn't begin with the letter P. So those two things would be here. Okay, so here you have a little introduction to sets, element, subset, Venn diagrams, and I'll just take you one step